Aloha mai kako kumui here. Thanks for the time and attention, guys. This is the second part on Unit 6 review, linear equations and their graphs. We're going to focus on writing linear equations in this video, but before we begin, I do want to share a joke. Why was the student's report card wet? It was below sea level. That's none of your tests, so you don't have to worry. Right? Okay, here we go. We're looking at focusing on writing equations of lines. All right, this is a huge skill and something we should be familiar with, but it contains numerous parts. There are numerous steps, so this can get a little more complex. Okay, this can be more challenging than simply graphing. There's a lot of moving parts here. So the first part is point slope form. First of all, we've got to remember what point slope form is. Point slope form is a form of a line that looks like this. It is the best form of a line to use. I wouldn't say best, I would say the easiest. It is the easiest form to write the equation of a line given a point and a slope. Hence, it's point slope form. You might be wondering, what is that other form again? That's slope-intercept form. That is entirely different, but I will show you. Slope-intercept. Think about it when you write it. Slope-intercept. I will show you how to use this as well, okay? To write the equation of the line. So in point slope form, let's review. Notice in black, Kumui's a little colorblind, so I'm not sure that's black, but the very dark parts of this equation, like here and there and there and there, the end parentheses, those are unchanging. That is the form of the equation, okay? That cannot change. What can change? M, that's where you'll put in your slope. And what else can change? That x1 and that y1. That can change as well because that's the point. There are three pieces of information that goes into this, and it's the slope and the point. Be very careful. The x, notice it appears on the left in the point form, of course. X comes before y, but it's going to swing here, and the y is going to swing out there. Do not put the x first, attach it with the y, and put the y with the x. Okay, you've got to maintain the right order. So let's memorize this equation, and that's something to just be aware of. Okay, careful about the switch. That's my note right over. Oops. I'm supposed to highlight that, not erase that. Careful of that switch. So let me show you guys. Let's practice writing the equation of a line with this as its slope through that point. Here we go. We have to first remember the form. Just for the sake of showing you, modeling, I will write the equation. I will write the structure of point slope formula. Okay, that is the point slope form. And I'm just going to start sliding things in. Y minus 6, because that's the y value. That's what I mean. Be careful. Get this value. Don't just have your eye go to the -4 and put in -4. Doesn't work that way. The slope is 2. And you have x because that you must have an x and a y. You still need x's and y's to have an equation of a line. If these were all numbers, you might just end up with something like this. Yeah, it's a true statement, but that ain't no equation of a line. It's just 3 equals 3. There's no way to graph that. Okay? So it's x minus, tricky. X minus a -4. You must write -4. You can't just write a 4 and say, oh, I already wrote the minus. No, the minus is in the formula. You need to bring the x value down, which is -4. Okay? And let's simplify this. Y minus 6 equals 2. We at least need to resolve these two signs, and that is our equation. Now, let's go a little further, just for consistency's sake. This problem is just asking for point slope form, so you can stop there. But it's my kuleana to show you the beauty of math and other ways to accomplish the same thing. So let's just put this in... we're going to put this in slope-intercept form. We're going to convert it. Let's distribute the 2. And let's add 6 to both sides. So you end up with 2x plus 14. Now, let's double check our work. The question on your mind should be this. Does this equation right here satisfy this information? Well, look. Look at your equation here. Does it have a slope of 2? Yep, it needed 2. Now, does it go through -4, 6? If you plug in a -4 for x, you would have y equals -8, because it's 2 times -4, plus 14, which is indeed positive 6. So yes, this is the only equation with a slope of 2 that goes through that point, and you nailed it. Okay, let me show you another way. This isn't called for in this question, but if you feel more comfortable using slope-intercept form to write the equation of a line, then this is how it's done. I always love to start out with the mold, y equals mx plus b. I know I wrote it to the left, but I'm writing it again. Step 1 is to plug in the slope. I like to break it down step by step. Now, from here, I need you to realize that the only thing missing from here to make a full equation of a line is your b. If you get the b, you're all pow. So, what we need then to get b is a value for x and the y. We need everything to be numbers except the b. How do we do that? Oh yeah, that's where this point comes in. Your y value is 6, your x value is -4, and that allows you to solve for the b. You have 6 equals -8 plus b. You add 8 to both sides and you get b equals 14. Now, what do you do with this b? It's very important. You take this b and you don't go back up the top. Nope, you go right here. And so the equation of the line will be y equals 2x plus 14. Notice how beautifully consistent this is with that. Okay, so that's how you write the equation of a line given a point and a slope. Now this is a different challenge. Find the slope. How to write, this should be write the equation of a line, right? The equation of a line given 2 points. Aha. You're not given a point and a slope anymore, but you're given 2 points. But remember, you need 2 pieces of information to write the equation of a line. You always need 2 pieces of information. You need a slope and a point. Slope, m, and a point. That is what you need to strive for, because then you can use point-slope form. But if you're given 2 points, yes, we have to understand we're not given the slope. We have to find the slope. No problem. You guys know how to find slope. So let's just do this, these points minus these points, okay? Those values minus these values. So we got 2 minus -4. Remember, it doesn't matter. Just be consistent in your order. Minus a -1. Okay? So this is going to be 6 over -2. We've got a slope of -3. Okay? Put that information right here. Bang. Keep it on the side. Now, at this point, you can use either one of these 2 points. I will prove to you that it shouldn't matter what point you use, okay? In this worksheet, it says use the first point. It doesn't matter to write it in point-slope form. I will show you that. So, point-slope form, if you recall, look at the top, look over your notes, okay? It's up there, point-slope form. Pause the video if you need to. Y, I'm going to use the first point here, y minus 2. Remember, your I needs to travel to the y value. Equals -3 times x minus a -3, so I'm just going to cut straight to the chase and say x plus 3. Okay? And I'm done. I'm done. Let's simplify this, though, just to prove a point. -3x, minus 9. Then we're going to add 2 to both sides, so you have y equals -3x minus 7. This is the equation of line. How do you check that? This is the cool part. Plug in -3 for the x. That would be 9 minus 7. We get 2. We needed 2. Good. This equation that we wrote has to also satisfy this point. So plug in a -1. -3 times -1 is positive 3. 3 minus 7 is -4. That is the point we needed right there. Okay, you see that right there. Now that's using the first point, but could you have also used the second point, meaning this? Yes, of course. We got to understand, guys, there is no first and second point in real life. They're just 2 points in a graph in space, okay, on a 2-dimensional plane. So let's practice slope-intercept form again. We're going to have y minus a -4, so let's cut to the chase. It's y plus 4. That's the slope. And instead of writing x minus a -1, I'll write x plus 1. Okay? Now let's simplify this because it better be the same as that. Notice this looks entirely different from that. So you might be wondering, uh-oh, Kumui can use different points. Let's see. Y plus 4. Let's distribute negative 3x minus 3. Let's subtract 4 from both sides, and we got y equals negative 3x minus 7. Wonderful. It ends up being the same thing. Okay. So, yep, guys, please make a note of that. I have a little graph here. Is that because I wanted to show you how to graph this? Yeah, okay, sure. We got 2 points, negative 3 comma 2. We could find the equation of a line from a graph as well. Did we satisfy everything? We changed the equation to the slope-intercept form. And, we need to change the equation into standard form. Standard form, what does that entail? Guys, just make sure the x's and y's are on the same side of the equation. Okay, so let's move the negative 3x to the left. We do that by adding 3x to both sides. We have 3x plus y equals negative 7. This is standard form. Okay. All right, let's come back to this. How would we use a graph to help us? We've got negative 3 comma 2 and negative 1 comma 4. Negative 1 comma negative 4. 1, 2, 3, 4. Now, how could we, if we graph, actually, I think the graph was just here to prove that we're in the right ballpark. Notice this equation, y equals negative 3x minus 7, matches this line. The y-intercept, even in my very crude graph, clearly the y-intercept is about negative 7, and it does have a slope of negative 3. First of all, it's negative, it slopes that way, and you go 1, 2, 3, across 1, across 1, 2, 3, across 1 puts you here, and 1, 2, 3 going up and across 1. Okay, there you go. All right, that concludes the second part of writing equations of lines. Again, that's might be a little shorter, but hey, there's this is pretty dense, so please review and study this really hard. Mahalo for your attention. Good luck. Ask me if you have any questions.